Alright everyone, so I'm going to try to do my best to explain the calculations for determining the molarity for your gene and vector. So in the lab manual, this is the formula that I have for you. So what we want to do is kind of use this formula to get the molarity of our solution, or basically we want a final concentration of mole over liters. So if we pretend that the PCR product I gave you was 20 nanograms per microliter, then we just have to put this value here. And now we can try to solve for the molarity. We can try to do the conversion. So the first thing we need to do is try to get this into liters. So for part 1, all I'm going to do is just set up the calculations where we have 2 times 20 nanograms over microliter. We want to convert 10 to the power of 6 microliters is in 1 liter, so that these can cancel. And then we also need to convert nanograms into grams, so 10 to the power of 8 nanograms is in 1 gram. And that should give us about 0.4 grams per liter. Oops. Liter. So that's the first set of the equation, just to get the grams over liter. Now we need to convert that into moles over liter. So if we continue with the, equation, what we end up getting is 0.4 grams over liter. Oops. Liter. At the bottom we have 3,075 base pairs, because this is how big our gene is. And then we have the moles times the base pairs, which will cancel here, over 650 grams, which will cancel here. So all that leaves us is moles over liters. And at the end, we will get around 2 times 10 to the negative 7 molarity, or really 20 nanomolar. So that's how you figure out the concentration, or that's how you convert the mass to molarity. And we're going to need to convert it to this molarity because we can't do that 3-to-1 ratio using just the mass alone. Because remember, if I remember, the plasmid is about 5,000 base pairs, while our gene is 3,000. So because the masses are so different, we can't just use straight nanograms to determine the ratio. We need to convert it to the actual concentration in molarity. So I hope that helps. If you guys have any questions, please feel free to email me again. But this is basically what you want to do. You just want to kind of calculate the molarity for each of them, and then this will give you, using these numbers, you'll be able to determine the amount of volume per ratio.